Hello everyone. Today I'm going to be telling you about a recent project that CIHT has been working on, all about the role of data and artificial intelligence, or AI, for achieving transport decarbonisation. For those of you who aren't aware of us, the Chartered Institution of Highways and Transportation, CIHT, is a charity, learner society and membership body. We aim to be the prime source of advice for national and local government and other strategic stakeholders when they are seeking technical expertise and knowledge to guide future policy and investment. With this in mind, last year CIHT identified AI as being an area in which there has been a sudden surge of interest, and it's something that many of our members were asking for more guidance and information on. However, we didn't want to write a report on technology for the sake of technology. Instead, we wanted to investigate how this rapidly evolving technology could be used to solve some of our sector's largest problems, such as transport decarbonisation. To do this, we formed a working group of 16 CIHT members and partners to gather their opinions on where the sector is at now and where we might be in the future. The report features a total of 21 case studies, and this will be the main thing I focus my presentation on today. However, just to note that these case studies were not chosen to recommend or advocate for the featured product over its competitors. They were merely used to build a picture of where we are currently at as an industry and to help bring some AI concepts to life. The project group chose 3 areas which they thought would have the most impact on transport decarbonisation, making sure that these also aligned with the Department for Transport's strategic priorities within their transport decarbonisation plan. We therefore gathered case studies on AI technologies that can be used for modal shift, decarbonising road transport and low carbon infrastructure. So let's start with looking at modal shift. Decarbonising transport is going to require a shift to cleaner, more sustainable and active modes of transport. In the Department for Transport's 2020 Gear Change Strategy for Active Travel, the government set a target for 50% of all journeys in towns and cities to be made by active travel modes by 2030. However, with last year's reductions in government investment for active travel infrastructure, the onus will be on local authorities and the private sector to be more creative and innovative in facilitating modal shift to public transport and active travel. And AI can potentially help to accelerate this transition. The project group found a large number of examples of AI technologies that can be used to measure and monitor various factors that influence decision making when it comes to modal shift. When it comes to sustainable transport use, AI technologies have been developed that use image and video analysis of vehicles and pedestrians, using roads and pavements gathered from cameras and automated traffic counters and sensors to provide insights such as how road space is being used, vehicle classification, traffic flow paths, speeds and journey times. And these kinds of insights will help decision makers measure and monitor levels of sustainable transport use to create a reliable database that can be then used to evaluate modal shift and target or identify areas of improvement. For maintenance needs, AI technologies have been developed that use image and video analysis of walking and cycling routes to monitor condition and serviceability for active travel infrastructure. For example, we profiled one company that equipped a mobility scooter with cameras which travel where cars can't to capture asset and condition data on footways and cycleways. We also saw an example of a product that conducts AI analysis of crowdsourced sensor data gathered from cyclists using their own personal bikes. This is an incredibly useful tool for decision makers so they have access to reliable information that reflects the user experience of cyclists to improve safety, reliability of journeys and level of service for users. Finally, we saw quite a few examples of smart traffic management systems that use AI to analyze data and control traffic lights to optimize traffic flow in favor of active and public transport, making them much more attractive and quicker options. Moving on to decarbonising road transport. There are currently 40.7 million licensed vehicles on the UK's roads, and this number is increasing. Decarbonising road transport and the movement of goods is crucial for addressing climate change. However, despite several UK government policies to help push towards zero-emission vehicles, uptake is still slow for many reasons, including a lack of charging infrastructure and the high price tag that comes with purchasing a zero-emission vehicle. It is therefore likely that the use of petrol and diesel vehicles will still be the prevalent form of car use well into the next decade. The project group found examples of artificial intelligence systems that can be used to minimise the impact of petrol and vehicle emissions, whilst also providing insights to improve infrastructure rollout to support electric vehicle uptake. Examples of this include using AI to reduce congestion by analysing real-time traffic data from various sensors and cameras to adjust signal timings dynamically, thus improving the flow of traffic so there are fewer emissions from stationary vehicles. In terms of supporting electric vehicle rollout, we found examples of AI systems that collect and process geospatial data, along with data provided by energy networks, to recommend the optimal type and location for a public electric vehicle charge point. We also found AI systems that collect data on grid capacity and energy prices, as well as weather, to automatically charge electric vehicles at optimal times, for example when prices and carbon levels are low. Finally, I'm going to quickly cover low carbon infrastructure. As an industry, we need to look at how we can deliver and maintain low carbon infrastructure, that is, infrastructure assets that produce fewer emissions throughout their life cycle. It is also important to remember that the PAS 2080 hierarchy tells us that our most impactful action is to avoid works. Build nothing, build less, build clever, build efficiently. Therefore, as the maintenance sector becomes increasingly data-rich, engineers can use AI to better assess asset renewal needs today and predict them into the future. For example, we profiled one company that uses AI for predictive modelling by taking historical data of an asset to forecast its deterioration and predict when they will need maintenance. We also looked at a product that uses AI to optimise local transport plans, balancing between different strategic outcomes such as carbon, cost, or customer needs, ultimately helping decision makers decide what new infrastructure to invest in, which will result in the lowest carbon emissions. So to summarise this very quick overview, the project group found that AI can currently be used for transport decarbonisation by making active travel a more attractive option, making it faster, safer and more reliable, supporting the rollout of electric vehicles through identifying charge point site selection and optimising EV charging, whilst minimising pollution of petrol and diesel vehicles by optimising traffic signals to reduce congestion. And in terms of low carbon infrastructure, it can help us predict the best ways to build and maintain our assets. To round off, I would just like to say that this report wouldn't have been possible without the hard work of our project group, so I'd like to thank everyone who contributed their time to pulling this together. I'd also encourage everyone to take a look at the full report and share it with your colleagues. I purposefully didn't name any of the companies or products featured in the report today, as I didn't think it would be fair to give some more airtime than others. But they are named within the report with links to all of the products, so I would encourage you to go check those out. The report also features a whole section on the future of AI and barriers to adoption, as well as recommendations, which I didn't have time to cover today, but again, I would really encourage you all to go and read that for more information. Finally, I would like to thank you all for listening. If you would like to reach out to me at all to discuss what you've heard today, then my email is on the screen now. Please do not hesitate to get in touch with any questions or if you'd like more information, or as well if you have any case studies that you would like to share with me with how you have used AI to help with transport decarbonisation in your role. I'd be really interested to hear about those as well. Okay, so thank you for listening, and I hope you enjoy the rest of the presentations you'll see today. Thank you.